Hey friends, welcome back. So let's start with a new topic, generics in Java. So first thing first, I have mentioned the few points here. So let's read out the notes. So generic is used mainly for type safety. So I will, if the interview asks what is the benefit of generics, the most important point is the word is type safety. You have to mention type safety is there with the generics. So we don't need to worry about the typecasting in the generics. That's where it's the type safety, and we should understand it conceptually also, and we will see it while running the code. Now the second thing is it is checked during the compile time. Most important point is it is checked during the compile time. It's not checked during the runtime, it is checked on the compile time. And broadly we can define generics at the two types, where one is at the class level like this one, and another is at the method level. Here at the method level also we can define the generics, and while going through the example scenarios we will cover the method level and class level generics. Then we will use the wildcard in the generics, bounded and non-bounded wildcards in the generics, and defining types at the method level also. We can define generics at the method level also and the class level also. So this is the generic defined at the method level. Okay, now let's begin. So this is the generic defined at the class level. Sorry, forgive me. And now let's start it. So I have just mentioned T is T is some generic here, and T can be of any type. T can be of string, T can be of input integers. So that is the benefit. So T, and then let's say input. So T is a input is a variable of type T, and what we can do is here is we can make it as string. So object will be, so here input will be of string type, and if I use again, suppose I use again generics in Java, and if I mention integer, generics in Java, generics in Java equals to new integer generics in Java. So it has automatically suggested that's cool. So see, now this T will be of integer type because we have put the integer here. So automatically it will take care. That's why we use generic. We don't need to worry about the type. Now let's go to the type safety thing. Okay, so let's go to the type safety thing. Suppose I have an array list. And I am not mentioning any type, and let's say list. Okay, and then I will say new array list. Okay, and then what I will do is I will add here list dot add, let's say I'm adding 3. Okay, and what I will be doing, I am getting the element at the 0th position into a string str equals to new list dot get element at the 0th position, right? So what it will suggest me to do typecasting. It is returning object, and we have to do the typecasting to the string, right? So see, we are adding 3, and when we are doing the get, we are typecasting it to the string. So if I will run it, definitely it will give the error, the class cast exception, right? So definitely it will throw that error. So that's where the type safety comes into the picture. So the type safety, what we'll be doing in the type safety is, see, class cast exception cannot cast to the java.lang.string. So you can give the example also. Interview usually ask the question, give me some example of runtime exception. So this is, we have seen class cast exception is the runtime exception, right? Now now what we will be doing is, to make it type safe, just we need to say it's a string type list. Now it will automatically give the error. See, now let me do undo. So see, this string is highlighted, it's bold, because this string is actually typecasting it. Now as I will do, so this string is now not highlighted, not bold. Why? Because it's not getting used. Why? Because typecasting is not required. Now it's a type safe. Okay, and now it is automatically giving, you can only add string, and it will automatically return string only. So we can only add string like this. So this is the way we can make the things type safety. If we will add 3, what it will give, it will say that string required string provided in. So it will check during the compile time itself. As I mentioned, Genrix will check during the compile time itself. It will not check during the runtime. Genrix is not for the runtime. Okay, so we will see overloading scenarios also. Okay, that time also it will check during the compile time. I will add one more time. Generics alone are not sufficient for overloading, method overloading. This also we need to note down, method overloading, right? So this is a complete list of nodes which we have and the information which we have regarding the generics. Now let's move to the next part. This is the method level, this is the class level generics. Now I will suggest you one good point every time. Suppose interview asks you to create your own list or own custom node. So what I have seen mostly rookies or mostly experienced also do custom node, and what they will do, they will do like this. They will make string as a data type, always string as data, and then custom node, next node, they will define next node, and then they will do previous node if it is a if they are building node for the WLink list, right? Previous node. So we have hard coded it is a string data type. It should be generic. So always write it like T. So it will really impress the interviewer. Always write it like the T. So now you can write it. Okay, you can build the custom node with the string type. You can build the custom node of integer type, right? You can build either of string type, custom node, new string, new custom node, right? And then you can build the custom node of integer type also, same here, if I can mention integer. So this way if you write the code always in the interview, it will always impress the interviewer. You should be confident with the generics. Okay, so if he will ask what is the use of generics, it's for the type safety which we have discussed, and while writing the code also we should make it as generic as possible. Okay, I will remove it now. In the class level generics, let's go to the new thing. We can make it bounded generics while declaring at the class level. Let's say it should extend the thread, right, or extend the thread class. So generics T should always extend the thread class. Here now it will be T will be always a thread type. We can't, yeah, see it's giving error. So something which should be extending the thread, right? So basically T is a now thread. So it means that generics in the Java is only taking a thread in the input. Input is a variable, and input is of T type variable, and where T is must be a thread because it is extending a thread class, right? So if it is extending a thread class, it's a thread. So that's why we can bound the generics, and we don't use implements keyword. We don't need to use implements keyword. If we want to use something which is a class which implements the particular class, let's say T extends string and implement, and we want to say it implements thread runnable, so we can say simply say extends only, no need to separately write implements. So extend is sufficient for the interface also and for the class also. Only thing is we should always write the interface in the end and the class in the starting. We can't do reverse. We can't add the interface in the starting and the class at the end, so it will give the error. See, let's see the error. To be the beginning of the bound list, class should be added to the beginning of the bounded types. So class should be added to the beginning. So we have done this one. So now it's much better. So we should not mention, or we can't mention implements runnable where T is a such thing which implements runnable. We can only mention T is a such thing which extends the runnable. okay, no need to mention it implement, because practically it's extending only, right? So that's why this is the reason why we use the extends keyword only. And we will come to the wildcard also. So we can't use here super or something. We can't use here super, or so it will throw error. So see, super. So I will cover during wildcard. So now it's basically throwing error, so I will just remove this. So this way we can bound the generics. We can use n number of things, and implements runnable and implements serializable. Okay, and we can do much more things. So we can add and make it more bound type generics. So T is something which extends the string class and implements runnable and implements serializable. Right. So this was the just scope to make a understandable generics. So then we can only add something which is or let's say if it's just say implements runnable. So let's say it just extends thread class. So here if we will add thread, then it will be valid. So this way we can resolve the bounded type generics. So I will be removing this for now, and I will keep it as a string, and I will keep it as an integer. So this is the class level generics. Now we'll move to the next thing, method level generics. So public, and then here before the return type we can define the type at the method level also. So let's say k is a method level generics which should extends runnable. I'm just saying, which is just a thread in this case. So we are defining the method level type. K is a type at the method level which extends the runnable. So wherever we will use k, it should be implementing the runnable interface, right? So now we can use the return type. We can say return type also as k, and then method name, right? So add thread, and what we can do is t input k input thread, because I made it as a specific to the thread, and something I can do is return k. Okay, so expression expected. Yeah, we'll do that. So here basically what we are doing is, if whatever is the k should be extending runnable. So we have defined the method level generics. So it should be one thing is to notice is that it should be always defined. We can say it's void also. Return type is void, and I will comment this statement for a while. So we will go back to that. So what we have done here is we have defined this k. What is this k? K is a type which extends, means which implements the runnable interface. So every time if we call this method, okay, so generics in Java dot add thread, right? So we can use one thing is we can put 1 to 3 in string. Why? Because I am using generics in Java. I can't add, so I will show you there. And then I will use I have to implement something which is extending the or implementing the runnable interface. So new runnable, and I can write this one void run, and something it should do, right? So I think I can do anything, just like system dot out dot print, and then 3, let's say just add, just for random. So now see, I can only put runnable interface. Why? Because it's k is something which will implement the runnable interface. If I do anything other than that, it will give an error. Let's say I give anything 2 3. So now I'm passing in integer. So provide required type k, and we are putting it int, right? Similarly, if I will write here it's 1 2 3, again it will give error. Required type is string. Why? Because we have passed already string. and we are using integer. So see, okay, so I can undo this one. So we can define here itself in the method level variable method level which type of which type we want, and then we can use same throughout the method. So we can use the same as a return type also, and so it will say unexpected token. So I should just put a return type also. Okay, k extends runnable, and I should remove void expression expected. Yeah. Oh, sorry. So what shall I do? I shall, instead of expression, right? So it should be expression. So my bad. So it should be k, and then something we can output thread. We can do it output thread, and equals to null. We can do, and then we can return output thread, right? So this will be expression. So yeah, we can return the output thread. So basically we are returning at something which is of type k, or what we can do is we can simply return input thread also. For a while we can just return the input thread. So return the input thread, that will also work. Or what we can do is, another thing is, we can make is k output thread, and what we can do is we can just make it runnable. So something which should be runnable interface, right? So new runnable, I can copy this one, and what I can do is, and then so see what it is saying is, if we'll go through, it's provided type k, and we are using runnable. So it still don't know the k type. It's saying that k is something which is extending runnable, and which is the input also, right? It still doesn't know the k type. So we have to use here, now we have to use the type k typecasting, right? Then it is working. So here still it doesn't know what is the k can be anything, so that's why we are typecasting it. Or we can simply do is something, mostly what will be there, it will not be required, something we will modify the input thread, and we can return the input thread itself. So that's the way this method level generics work. Now let's come to the next point, which is wildcards in the generics. So wildcard in the generics, so let me yeah, so I will add elements. Let's say add element, and what I will be doing is I will remove this one. I will, let's say it's returning void, and let's say it's there in the array list, and then so wildcard is this question mark is a wildcard, and what we can mention is we can just simply do array list question mark itself, and then input element. So this is unbounded wildcard. There is no boundary, means it's not extending or it's not a super. So what we can, we can't add it. Suppose there is an array list. Okay, suppose there is an array list of type object or anything, or string type is there. Okay, and list. Okay, let's say it's equals to new array list. I'm just writing it here. It should be or let's make it at the class level, and that will be better, right? So list, and let's say I'm adding list dot add e input element. So it will give error because we don't know what is the question. The question can be anything. So that's the reason if it's capture of. So I'm not going into the exact error here. So the basic thing is we don't know what it could be, integer, it could be string, it could be number. So we can't add if we are giving wildcard expression like this one. So what we can do is we can just add null in this scenario. We can add null only in this scenario. Otherwise we can't do add operations here because we don't know the input element could be of anything. And there could be a wildcard where we can mention extends string. So that time also we can't add anything. We can't add anything could be there, right, which can be extending the string. First time it could be suppose there are two classes which are extending string. One is a class A which extends string, one is a class B extends string. So what you will do, you will write A adding the string, and then next time you can do is B adding the string. So that's why also Java doesn't allow so you can't add A, B, C. Okay, so or you should not add also, because some other person can add A extends class A extends string, and some other person can put class B extends string. So that's why you should not do that thing. So this is a bounded wildcard where this will always extend the string. So last is super. So before moving to the super, so extends. So it should be input element here. So suppose A could be the class which is extending the string class. B could be the class which can extend the string class. So list will not be aware. So Java will not aware that which type is being added. It could be A here, it could be B here. So that scenario will not be clear to Java, right? So that's why we can't add input element. We can't add input element to this list. And similarly for this scenario where it's only unbounded wildcard, we can't add anything other than null. For both of this, we can't add anything other than null. And the last case is super. So for super, suppose super is string. So for the last case, super. So suppose string is extending class ABC. Suppose string is the class which is extending ABC class. So ABC can be the input element because ABC is super to the string class. Suppose string is extending D class, so D can be the input element because D is the super to the string class. And suppose D is extending Z class, so Z can be also the input element because Z is super to the string class, and we can add that input element as well, right? So we can add here, we have made it to the string. If anything super to the string is there for our example case, then we can add it. Then we can add it like for the input element here. So that scenario will perfectly work. We can add anything which is super to the string class, and that should work here. Okay, so hope you enjoyed the content. Meet you in the next topic, and till then, goodbye friends, bye bye.